there was a need at the new company, and I said, I can do that. I'm ready for this adventure. It just kind of took off from there.
Hello and welcome to the Being an Engineer podcast. Today, we're so excited to be speaking with guest John Martell, a seasoned mechanical engineer with over 14 years of hands-on experience spanning aerospace, medical devices, automation, and geospatial drone services. He currently serves as Director of Data Management at AeroVelocity and brings a unique blend of technical leadership, creativity, and passion for both engineering and music. And this is a special treat for me because John is a former coworker of mine. We worked together at Pipeline for many years, and he is just a wonderful person, a super talented engineer, and it's just a pleasure and a delight to get to catch up with him and talk again and share some of the insights and engineering wisdom that he has picked up over the years. So, John, thank you so much for being on the show today.
Yeah, thanks, Aaron. I appreciate you inviting me on the podcast.
So, thinking back to when your engineering career first started, or before maybe, what was it that made you decide to become an engineer?
Well, obligatory, used to play with Legos all the time as a kid story here, but partially true. My grandpa was a mechanic. I wanted to be a mechanic because of that. I was really interested in cars. But I talked with my mom about that and my grandpa about it. And they said, well, instead of working on cars like as a mechanic, why don't you maybe design the cars one day? And so that was in my mind. And then I took shop class and I liked math and science. I took other engineering classes, welding classes, and it just kind of built on itself to the point where, yeah, that's what makes sense because I think I'm good at it and I like it. I will apply. I initially applied and got into ASU as aerospace, but I transitioned to mechanical because I thought it would be broader based on my experience. I thought it would be a better fit. And, yeah, that's where it started.
Do you ever think back and wish, darn, I wish I stayed with aerospace? Or are you pretty happy that you went the mechanical route?
I think I was pretty happy with mechanical. Yeah. I don't regret not staying in aerospace. It's something that I think of like, oh yeah, I started with that instead of, darn, I should have stayed with it.
I know what you mean. I actually started in manufacturing engineering, and it's funny to think back sometimes that was my initial major. And then the university where I went, they actually ended that program while I was there. And so mechanical was kind of like the default other option. So I went into mechanical, and I'm really glad that I have now. Like you said, it's a more broad major. I think it's kind of the Swiss Army knife of engineering disciplines.
Yep.
All right. Well, let's talk a little bit about the time when you were at Pipeline. So this was it was about 6 years, something like that, that you were there. And you eventually were a project leading projects, and we did a lot of fixtures. And towards the end of your stay, we were getting more and more into automation, and you led many of those projects. Can you think of one of those projects that taught you something pivotal? That's not a word. Pivotal about the design or process optimization.
We did a lot of work for and we were working. I was helping. One comes to mind. I was working on a project with Noah Burke, who you had in a podcast recently, and Mark Blakey, who are both great, awesome guys to work with. And some others, as well as part of this project. But sometimes, at least the projects that we were working on, the scale of the product varies so much, and getting into this one that we're trying to solve, there was this needle. We're trying to make this needle, trying to place the end of this device, the distal end, in a certain location. And something that what I learned and what was clear at that point was sometimes you think you have an idea, a good way to do something, but you just have to go back to the drawing board several times. Even though you think you might have a good solution, you test it out and that's not the right way to do it. Sometimes you hit a home run right away. And I would say pivotal is just having the patience and reminder. Just have patience when you are trying to do the right design. Make sure that you're doing it correctly in the right way. And things take more time sometimes than you think they will.
I feel like we were learning that lesson frequently. It always takes more time. That what we do at Pipeline, it's such a double-edged sword. It's super fun because we're always doing something new and interesting, but at the same time, it's always new, which means we're always climbing that ladder of invention and figuring out, all right, how do we do this? No one has ever done it before, so we need to figure it out. So a lot of fun, but some challenges when it comes to getting things done in the amount of time that we quoted.
Yes.
Let's see. You have this knack for designing mechanisms. And I was always so impressed with the mechanisms that you came up with, right? There's these mechanical linkages or things like that facilitated motion in a certain way or performed some kind of work really cleverly without having to resort to electronics or things like that. What's your process for designing a new mechanism?
Well, first and foremost, the inputs and criteria requirements are vital to the success of a mechanism doing what it needs to do for the end customer. So that's first and foremost. You have to have those written down either in a requirements document, which is optimal, or even just for your own notes. Like this needs to do this and it needs to do it like this. Even additional notes for yourself, for myself, I write so that I can think of, and when things come to mind, make note, like I would like it to be easy to turn, or some things that might not necessarily be on the requirements document, but it aids in some conceptual ideation there. I can also visualize well, so I try to envision the required motion when I hear of the problem. So I think about what this mechanism needs to do. So I guess that's part of my knack, maybe, I'm able to have it in my head, but then I need to get it down in CAD and we need to make it. But so going from the inputs, the next step for me, I usually and most always actually use pen and paper, like a notebook, a design notebook, and just make a bunch of sketches about like, this is here, this is there, things that move. If you have a device or an item that you're trying to interface with, your brain just thinks differently and works differently through pen and paper. It's crazy. You can think of something, maybe even just going into CAD would be good. But if you go to pen and paper, and it's just practice, like more and more drawing makes better and better sketches. So I've been sketching and drawing my whole life. So I guess some people haven't been doing that, but I highly suggest to start right away. Practice sketching. So sketch what you think you need to do. Might not even be the whole mechanism, but then sometimes just sitting on it and getting distracted, coming back to it, that's helped me a lot too. So you do some sketching. I often do a Google search, an image search of something that comes to mind, make notes, a lot of back and forth. This is just like iteration of chicken scratch sketches, sometimes CAD, but usually sketches. And after I have maybe something reasonable in a sketch pad, sketchbook, I go to SolidWorks, let's say, and make a movable sketch. That's usually the thing I do next. Is in SolidWorks, you can make a sketch and have it static with dimensions, and it gets black because it's all constrained. That's good. I make that a first position and an end position, initial and final position, with the same length of linkages. Then I make a new sketch. I feel like I'm rambling a little bit.
The Product Development Expo, or PDX, is your chance to learn from subject matter experts providing practical, hands-on training for dozens of different engineering topics. GD&T, Advanced Surface Modeling, DFM, Plating and Finishing Techniques, Programming Robots, Adhesive Dispensing, Prototyping Tips and Tricks, and lots more. PDX happens October 21st and 22nd in Phoenix, Arizona. Learn more at pdexpo.engineer. That's pdexpo.engineer.
No, keep going. This is great. I like that you talk about the Google search as well. I think that's an underutilized tool, right? We always try and create things like from scratch all by ourselves, but there are already so many ideas out there. And you might not use an exact idea that you find out there, but it serves as good inspiration. I recall there was some website that you would reference on occasion as well, right? Like 101 mechanisms or something like that.
501 mechanical movements.
Yes.
That's it. You can actually go to 507movements.com has many that are animated now, actually. I use that a lot. I told other engineers about that site a lot. There's also a book that I have as well called Mechanisms and Mechanical. I have it over here. Yeah, that's it. Mechanisms and Mechanical Devices. If you're looking for really good inspiration, you could look at that book as well.
Mechanisms and Mechanical Devices and 507 mechanisms online, right?
507movements.com.
Movements, 507movements.com. Great reference sources.
Oh, yes.
Nice.
Because a lot of times you don't need to reinvent the wheel. You just need to change the size, reinvent the spokes, the interface, how it attaches to the car.
Yeah. I find that to be one of the challenges that engineers have to overcome. Is we're engineers because we love creating new things. We love designing new things, but we don't always need to design something new. In fact, oftentimes I feel like the engineering goals and the commercial goals can be at odds with one another because the engineer wants to design something even better, right? That's perfect and new and interesting. But the commercial goals for any engineering organization are to do it as fast as you can for as little money as you can. And oftentimes that just means finding something that already works and maybe, like you said, retrofitting it a little bit so it interfaces with your application.
So after you do the research, like I was discussing, I would go into SolidWorks and start making that movable sketch. What I was trying to describe was that you make a mechanism in a start position and an end position, and then you close that sketch and then make a second sketch that has the mechanism parts constrained by the length and the pivot. Like if we're making a 4-bar mechanism, let's say you have the 4 bars, the same length and the same pivot points as that main sketch, but you don't constrain it so that it cannot move. You make it so that it can move, and you can actually see the motion in that sketch, referencing that first sketch. And then if you need to change it a little bit, you can modify the first sketch, close out, remove the second sketch, not remove it, move it again. And you can see it move around, and see if it'll do what you want it to do. I've also used Excel and reference equations for mechanisms to ensure that I'm using the right mechanism or right linkage, let's say, for the right application.
Yeah. That's great. Thank you for walking us through that process. I think that sketches in SolidWorks are probably also underutilized, and they can be super powerful. There's a trick that I used to use back in the day when I was doing a lot of CAD, where I would create a free body diagram in a sketch, and I would apply the forces, and I would use lengths to designate the force. The word is escaping me. The force values, the magnitude of the force, not just the magnitude, the vectors also. That's why it was helpful doing it in a sketch. And then as I changed, one of the loads or one of the force vectors, everything would update automatically, right? Because it was in a sketch and I had different constraints and equations that were driving everything. And that was a really helpful way to utilize sketches to visualize how a system, a free body diagram changes as you manipulate different values.
Yep, that's definitely helpful.
All right. Well, at Aero Velocity, you're now managing data related to drone geospatial services. How did you make that leap going from, because you were you did a little bit of software as well, but you were primarily mechanical in the work that you had done previously, and now your data and software, which is very different than what you were doing before. How did you make that jump, and what have been some of the learning curves or surprises, things that you didn't expect? How is that all going?
Well, I did a lot of Excel work and code like macros for Excel and for SolidWorks. And I also helped implement PDM, SolidWorks PDM at Pipeline, and also before that at my company prior to that. And so I was kind of in the realm of that as some specialty of my experience, I would say. And there was a need at the new company and a shift. And I said, I can do that. I'm ready for this adventure. And it just kind of took off from there. I was already recognized as someone able to lead that department or portion of the company. And so what we do now is we analyze and take the data from drones data captured using drones, LiDAR, MSI, and we store the data, we analyze the point clouds, and we track the progress of the projects and interface with the customers as needed, delivering the products to them.
If you can talk about it, and no problem if you can't, what are your drones used for, and what's the goal, the objective of acquiring and analyzing all of this data?
Yeah, certainly. I can talk about that. So one use case is in Mississippi. There are a lot of dams and watersheds. So we help them to gather data instead of a surveyor with a stick and a sensor, a laser. We use our drones to scan the profile of the dam to make sure that it is not compromised in any way, especially after a big storm. And so they get a lot more data using the drone scanning, and it's safer for the operators because they don't have to be near the alligators and the other wildlife in and around that area that's not normally traversed by human traffic. So it's a win-win in that case. We also scan farms for the farmers, especially who have irrigation fields for rice and soybeans, and they need an optimal place to place polypipe, which is a method of irrigation that a polymer pipe thin pipe that could be 12 inches in diameter, 15 inches diameter, that they poke holes into, and the water escapes on one or either or both sides of that pipe. That's placed on the field at some point in the farming process, and they need to have it in a good location in order to properly water the whole field. And so we gather the elevation data for the fields, and we help to recommend a certain paths for that to go. So we give them that information in a report and different geospatial files that they can use, and the CSV that they can plug into their tractor if they need to, and follow that path.
Very cool. I did not know that you could plug a CSV into a tractor. This is news to me. So do you sell these as like kits that the purchasing organization then uses, or you do all this as a service?
It's a service that we take our drones down to the location that is needed and scan the area, and we bring the data back in-house, and we then provide the information at the end of our analysis to the farmer or the entity that would like it, and then they can use it as they need to make decisions and improve their process.
Very cool. Very cool. All right. Well, let me take a very short break here and share with all the listeners that the Being an Engineer podcast is brought to you by Pipeline Design and Engineering, where we don't design pipelines, but we do help companies develop advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services. Learn more at teampipeline.us. The podcast is also sponsored by The Wave, an online platform of free tools, education, and community for engineers. Learn more at thewave.engineer. And we're speaking with John Martell today. So John, you've managed both younger junior engineers as well as senior engineers. Do you have any advice for engineers who are interested in making that transition from an individual contributor to engineering leadership?
Yeah, I think it is important and good to look at what your superiors and previous superiors do and don't do that you like and don't like, and think about the lessons learned that you've witnessed as you're going about your current role and thinking about your past experience. And if you're currently transitioning to a manager type role, it's good to find a way to get past the imposter syndrome that you may have, because I went through that. You have to ensure to remind yourself that there's a reason why you're getting this new role, and at the same time staying humble and knowing that you don't know everything, and you're still in the middle of a transition. So just give yourself a break.
Wonderful advice. Really, really solid advice. What were some things that you did to overcome imposter syndrome?
Some of it was a fake it till you make it kind of thing.
I love the honesty. I've certainly been there.
You have to believe that there's a reason, like I said, the reason why you are where you are, and people listen to you for a reason. That's why I said stay humble, because people will listen to you, listen to what you say. And if you get too egotistical or cocky or whatever, and you're not remembering why someone might have put you in the new role, then your words, what you say and don't say, could be taken out of context, and there's a whole mess of repercussions. Just, yeah, you have to be extra careful, but you don't have to be too careful. I think it's good just to be yourself.
Yeah, good advice. be yourself. Let's talk about some of the tools that you've built over the years, not just physical tools, but software tools as well. You mentioned doing a lot with Excel macros. I know you've got some experience with Python and of course, lots of SolidWorks experience. Thinking back, can you identify maybe one of your favorite tools that you've ever built? It could be hardware as well, up to you. And what was special or unique about it for you?
Thinking back, doing all the work for we had a lot of exports that we needed to do for them. A huge drawing package. It's not something that SolidWorks has built in, so I made a macro to automatically export all of the common files like PDF, step, etc., and place it in a format that they requested. So I made a macro that had several steps to it, and it was kind of elaborate, but it worked. And I was pretty proud of making that and helping to save time with save pipeline time and get the products to them faster than if we were to do every one of them manually.
I remember this. It was for smaller drawing packages, not that big a deal. But like you said, for larger drawing packages where maybe there are, a few hundred parts in there, it would take a long time because they wanted not just, a dump of all the files, but a very specific folder structure, folders within nested folders. Some of them were zipped folders and others were just loose files, but a very specific configuration of all of this. And when you have a big assembly and you're having to create, right, the PDFs, the step exports, the native files, all in different subfolders and zipped folders in a very specific structure, it would take easily days for some of these larger assemblies. And then with your macro, I think it was literally the human time required was a few minutes, something like that. So it was an incredible time saving, something that was really cool and heavily utilized by the whole team. All right. A lot of the podcast listeners, not all of them, but a lot of them are younger in their careers, maybe the first 5 years or so. What are a couple of things that you wish you knew when you were a young engineer that you know now?
Can your project benefit from simulation? Get in touch with the team at Simitech Group, a trusted partner in engineering, simulation, and consulting. Simitech Group empowers engineers with cutting-edge ANSYS simulation software, expert consulting, and comprehensive training. Whether you're tackling structural analysis, fluid dynamics, or electromagnetics, their team of certified engineers helps you innovate and optimize. Join the ranks of top-performing engineers who trust Simitech Group to bring their ideas to life. Visit simitechgroup.com to learn more and discover how they can support your success.
Yeah. Part of it might be just new to the corporate or business world, like out of college, basically into the job world. Part of it might be engineering related, but what I wish I would have known was how fast it goes by and not to take your health or active nature for granted, because you could get stuck behind a computer screen or in front of a computer screen, I guess, if you want to look at the front of it, for longer than you might want to if you don't take breaks and move around, and it can take a toll if you're just sitting in front of a computer. It's not just engineering, but just in general, it's good to take breaks and go walk around multiple times a day, go talk to people, be social, be active, and don't forget to play even in your elderly 20s. and 30s.
Yeah. Yeah. Recently, I work right now, John and I were just talking about this before we started recording. I had ACL surgery a couple weeks ago, so I'm not extremely mobile at the moment, and I'm used to being pretty active, working out several times a week and doing jujitsu several times a week, and I can't really do any of those things. Certainly not the jujitsu, but I can do a little bit of weightlifting. So what I've been doing lately, I can't really do a full workout, but I've been setting up the home gym just so I can go in there every hour or two and just do a quick set of 4 different exercises. And it takes literally 3 minutes to do this. And it's great. It gets the blood pumping and it gets my body moving a little bit. And I don't have to spend the full time doing a workout. I can't really do a full workout in my current condition anyway. But I get in there for, 3 minutes at a time, 2 or 3 times a day. And it really helps break things up. And I always feel more energized and, some mental clarity after moving my body a bit than just, like you said, if you let yourself fall into that trap of sitting for hours and hours on end. Oh, it takes its toll. It happens quickly.
Yeah. And I liked how, at some point you had gotten that rowing machine at Pipeline, and you would go in there. I would go in there sometimes and just get on there and start moving my body. And
yeah. What is one common way that you have seen engineering teams fail?
Well, bureaucracy and not having the same sense of shared purpose. I've seen that. And, there's been toxic. I just wanted to bring up at this time, the culture that you have created, starting at, I think maybe before I was there, but when I was there, the core values that you instated, I think you instated those while I was there. And those are treat our customers well, treat our team members better, govern my productivity, not bureaucracy, suffocate chaos, promote order, prevent surprises. And also the mission statement to promote joy in the lives of our team members. I think those are ways that you ensure that engineering teams work together well and do not have a failing morale, especially. And I just wanted to thank you for introducing that to me, because I've tried to replicate that in my current and past position at Workhorse. I was previously a Workhorse Aero, and then now at Air Velocity, trying to, I think one of the good books that you introduced me to was Culture Code. And I have tried to remember the points that he tried to make in there. Vulnerability, safety, and then, purpose. And so I try to, in little ways here and there, tried to replicate that. So I appreciate that. That's one thing, one way that engineerings are better off is because of the communication and morale and the team sense of team that is brought out from those tactics.
Thank you, John. It means a lot to hear you say that. Thank you very much. I have thought to myself on more than one occasion, because I think what we do at Pipeline, it's kind of a tough business. Yeah. We talked before about how everything we do is custom. And so we're always inventing something, and there's inherent risk when you're inventing something, right? Things never quite go exactly how you expect them to go. And I think that one of the reasons we are still alive and thriving as a company is because of the culture of the team. Everyone, they work together, they support each other, they like each other, they help each other. There aren't really any siloed departments where they're throwing things over the wall and saying, that's not my problem, that's your problem. It's just not like that. Yeah. And there's very little policy or bureaucracy. Everyone just works together to be productive. And I really think that's one of the reasons that we're still around after 15 years. So anyway, thank you for saying that.
I think it is. And the way that you have a customer base that is return customer base, I think is also that, or because of what and how you've treated them and how you interact. It's a personality game at that point too. Not a game, but it's how you've treated them as well.
The only way that we get anything done is with and through people. At the end of the day, it's all about relationships with people.
Sometimes the biggest one is no surprises.
Yeah. Yep. That's right. Yeah. Got to prevent those surprises. Michael Hadley, who, you know, very well, John likes to say that bad news doesn't age well. So get it out there early.
Yeah.
All right. You've been a musician for quite a while. In fact, you know, I just remembered this right now as we were talking. Okay, so all of you listeners, you are in the presence of greatness right now, which is, I'm sure, already clear. But the intro to the Being an Engineer podcast, and the outro for that matter, was created custom by none other than John Martell here. So among many other pieces of musical genius, but that one was, it was generated all by John. So thank you for the beginning and ending of over 280 episodes at this point.
Sure, yeah, no problem. It's fun. It's fun. That's what it is.
How does musical creativity influence the way that you think about engineering problems, or does it? Are they completely separate?
I'm not sure that influence is the word that I would use, but I would see that they're a similar creativity outlet. I think, slightly different parts of the brain, maybe a lot of engineers are musical in some instrument, I think. But I can correlate the creativity and diversity of music and musical styles with the diversity and diversity of solutions to a problem, let's say. So I think if you're musical, you can visualize it. You're not visualizing music, but it's similar to how you can visualize an object. You can kind of think about the sound or the melody. I would say there's a correlation for me there, I would say.
Yeah. Yeah. I don't have the musical talents that you have, for sure, but I have always really enjoyed music. And there was a time when I started to learn the guitar, and I didn't get very far, to be honest. I probably got about 7 or 8 months into it, and I could do, you know, really basic things, but it was so fun. It was so satisfying just hearing the notes and strumming the guitar, playing along with a song in the background. And I think there is something to that about just how the brain works, and music unlocks thoughts that you might not have had otherwise. It unlocks creativity that you might not have had otherwise.
I've always listened to varying genres while doing CAD or while brainstorming. And I think the way that my brain works, and maybe it's a common thing, is I think a part of my brain, talking about this music in this way, I think part of my brain needs that distraction or something to latch onto in order for the part of my brain that's doing CAD functionally to be efficient or to be guided in some way. It's hard to explain. I thought about that in my first job when I was doing CAD work back then. And I was doing, listening to this really complex music, thinking about how can I almost multitask, if you will, in this way. But it's not, it's obvious. You're listening, and it's passive, but I think part of your brain just gets a little bit of fuel or relaxation or something psychological.
All right. Well, let's see. Just, I think a couple more questions and we'll wrap things up here. What is one thing that you have done or observed to accelerate the speed of engineering?
I think one thing that comes to mind immediately is something we already talked about: macros, scripts, code, automation, improve the speed of work immensely, especially for the mundane tasks or things that you just have to do a bunch of clicks the same way every time, or even maybe a little bit different each time. But those types of things, automating the clicks, automating the input, help immensely. And that's a lot of what I've helped to manage and help implement in my current position too, is to implement code, Python scripts, for automatic PowerPoint creation, for instance, from data. So in a pipeline, I made several Excel macros, SolidWorks macros. Those really help. The other thing too is just something besides what we already talked about, just getting feedback early. It's kind of like failing early, getting feedback and talking to someone else early on so you don't go off in a rabbit hole dead end helps immensely. So I greatly recommend that to teams, to just have regular meetings to discuss, or just ask to help. If you're a manager, just ask, how's it going? Do you need anything? Or do you have anything that I can review? And usually the other person is happy to oblige and go over the problem at hand, and you can say, yeah, that looks good, or actually, maybe you can try this because when I did XYZ, this was better. What do you think?
Yeah. Having, I remember when I was a lot younger and hearing about how companies would struggle with various problems, I would always think to myself, why don't they just hire a consultant who knows how to do that already? And, part of that was I was young and naive, but I think there is some truth to that. And in a sense, that's what you're saying, right? As the manager, the senior engineer, the subject matter expert, you kind of serve as a internal consultant, right? So
Yep.
The engineering team doesn't have to go through the failures that you did when you were younger. They can just turn to you and say, well, what do you think about this, John? And you can guide them in the right way.
Yep.
Yeah. All right. Well, John, thank you so much for being on the show. It is so nice to see you and have a chance to catch up with you again. Anything else that we should go over that we haven't talked about yet?
I can't think of anything. I think it's been really nice to talk with you, catch up, and thanks for having me on.
All right. And how can people get in touch with you?
LinkedIn. I'm on LinkedIn, linkedin.com/in/John-Martell.
Perfect. And we'll put a link to that in the show notes as well. Great. John, thank you so much again for being on the show.
Thanks for having me.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.